Welcome to the world of a kidney. I'm Michael Martinez, Ariana Thompson, Alex Zawadzki behind the camera, and Avery Chen will introduce our key right now.
So this is just a basic, I'll just briefly describe what the key is. So if you see this light green puff ball, that's glucose. This black ball, that's poisons, drugs. The white one is urea. The yellow glittery object is urine. The red glittery object is oxygenated blood. And then this one is obviously deoxygenated blood. The orange is amino acids. This particular green is water. And the purple glitter is salt.
Please note that our key is based on colors and not
Glitter.
Yeah, it's just based on color, not the shape.
For example, the red puff ball is also blood.
So,
all right.
anyways.
So the blood is delivered into the kidney, and it comes from the aorta and it enters through the renal artery. This then disperses and it goes to the medulla, which includes the loop of Henle, which we'll talk about later, and most of the collecting duct, but specifically this millions of nephrons. So this is our nephron over here, and here's where it enters through the renal artery, or the efferent. That was with an A. And then it goes into the glomerulus.
So the glomerulus is a little ball of capillaries, and this is the premier site of ultrafiltration, where all these fluids come in, and yeah, you can see the animation. So the ultrafiltration is only based off of size. If the molecules are small enough to fit through the glomerulus, they will continue, and if they're not, they're reabsorbed back into the Bowman's capsule. Then, after this ultrafiltration has occurred, it enters into the proximal convoluted tube, where the reabsorption of most salt and water occurs. And as water is flowing through the proximal convoluted tube, it's driven by, it follows osmosis out of the tubule through passive transport, and the proximal convoluted tube controls the pH, a lot of the pH in the body fluids.
And you can see right here, here is a close-up, and you can see that it is, it has many microvilli in it, which helps with reabsorption, like one of the other cells we've been studying.
The small intestine.
Okay, and so we'll just go back to the Bowman's capsule. It's hard to see, but this square right here is just a more detailed diagram of ultrafiltration, and these are just the molecules that are listed that are in the blood as well. And then if the arrow points out to what can become the filtrate and what cannot, it stays here. That's just ultrafiltration, really. You see this? This is a capillary wall right here, and the small straight line, that's the basement membrane, and then this is the podocytes. Like the semi-half squiggly circles are podocytes. Sorry.
All right, so after the proximal convoluted tubule, we go into the loop of Henle, and there's two parts of that. There's the descending and the ascending.
In the descending part of loop of Henle, which, yeah, is right here, it is permeable to water because salt is...
The salt, there's more salt as you go into the medulla deeper.
So an osmosis occurs.
It's just due to salt concentrations.
However, on the way up, on the ascending part of the loop of Henle, it is permeable in opposite only to salt. And in the beginning, that's passive, as there is less salt on the other side of the membrane, and this is in the inner medulla. However, once you enter into the outer medulla, this is when it becomes active, and they really want to get that salt out, but since the concentration is either the same or greater on the other side, it must be done through active transport, and this requires more cells with mitochondria to have more ATP. So that's why you see here, there's mitochondria, and that's just a blow up of that little part of the cell. So it just keeps on going, and then it goes into the distal convoluted tubule, which you can see right here.
And so in the distal convoluted tube, this is really just the final side of secretion of toxins into the urine. So you could say it's like the final step towards creating urine. It is the final site for selective reabsorption. What it basically does is it regulates, you can say it regulates pH levels by regulating potassium ions and salt concentrations as well. And it's controlling the pH of body fluids by secretion of hydrogen ions and reabsorption of reabsorption of bicarbonate as it goes down here. This is essentially just the collecting tube. It regulates water and it's sensitive to ADH, which is for osmolar regulation, and it just pretty much delivers urine to the pelvis.
All right, and the urea, which is collected in the collecting tubule, will come out of the nephron through here and down through the ureter, where it will go to the bladder, and then eventually you will excrete it. Now, simultaneously, while all of this is happening, the blood is continuing to flow through the kidney, the nephron, in order to provide oxygen and other needed nutrients to the cells of the body. So throughout this,
The capillaries.
Yes. The blood will be flowing and becoming deoxygenated, where it will leave through the renal vein, the efferent vein. And so here's in the nephron. It will come out of the renal vein, where it'll eventually go
Back to the vena cava.
Yes, back to the vena cava and to the heart.
Thank you.
The rest of it is regular.